Number 3 reads, what is the force of gravity on the moon due to the Earth? The radius of the moon's orbit is 3 times 10 to the 8th meters. So let's try this out. First we'll make a little sketch. Here we got the moon, which is supposedly made out of Swiss cheese. That's still under research here. And then here we got the Earth. And according to Sir Isaac, there is a equal and opposite gravitational force of gravity that acts on these two objects. And we can solve that by breaking down all our information. We want to find the force of gravity between the two objects. We know that the radius of the orbit is 3.8 times 10 to the 8th meters. And then we just need to know the mass of the Earth and the mass of the moon. We'll be okay for each object. So this was given on our previous page. The mass of the Earth is 6 times 10 to the 24th kilograms. And the mass of the moon was given as 7.3 times 10 to the 22nd kilograms. And we can use our universal constant G, 6.67 times 10 to the negative 11th newtons meters squared over kilograms squared as a proportion of gravitational constant for our equation. So now we can plug in to our gravity equation. G m1 m2 over the radius squared. So finally in step 4, let's put in all the numbers. Okay, force of gravity is equal to 6.67 times 10 to the negative 11th multiplied by 6 times 10 to the 24th multiplied by 7.3 times 10 to the 22nd, and that whole thing gets divided by the radius, 3.8 times 10 to the 8th. And we don't have to worry about units because we already have everything in standard metric units. So let's go ahead and plug and chug. The force of gravity between the Earth and Moon is simply universal gravitational constant, 6.67 times 10 to the negative 11th times the mass of the Earth, 6 times 10 to the 24th times the mass of the Moon, 7.3 times 10 to the 22nd divided by the radius squared. Aha, gotta make sure I didn't mess that up here in my equation. So I gotta use parentheses, common mistake. 3.8 times 10 to the 8th meters. 380 million meters away is the moon. We have to square that, and when we do all that, we get about 2.023 times 10 to the 20th. Which is pretty close to the answer given, just a little bit difference in the rounding, probably because we use some rounded values for the mass there. But no big deal. In a nutshell, that's part A. Next, in part B, it says the moon takes 27.3 days to orbit the Earth. What is its speed? So if you recall, if the moon is going around the Earth here in a circle, we can find its velocity by taking 2 pi r, the distance around a circle, divided by the time. So we do know the radius of the orbit, which is 3.8 times 10 to the 8th. But what we want to do is convert days into seconds. Okay, so a time of 27.3 days. We can think of this as being over 1. We're going to get rid of days, go to hours. In 1 day, there's 24 hours. So we cancel out days, we have hours. Then we can get rid of hours by putting it on the bottom. Go to minutes. In 1 hour, there's 60 minutes. So now the hours cancel out, and we have minutes. Almost there. Now we can get rid of minutes by putting it on the bottom and go to seconds. And in 1 minute, there's 60 seconds. So now the minutes cancel out, and we finally have seconds. So notice we're taking the time of 27.3 days, and we're multiplying it by a 1-to-1 ratio of time units. So we don't change the actual amount of time, just the units. In 24 hours, there's 1 day. In 1 hour, there's 60 minutes. And in 1 minute, there's 60 seconds. So all we do is we take 27.3, we multiply it by 24, and then we multiply it by 60 twice. And we get 2,358,720 seconds. Woo! 2358720. 2358720 seconds, which is what we'll substitute in over here for time. And so finally, we can solve for the velocity by simply taking 2 times pi, 3.14, times the radius of orbit, 3.8, 3.8 times 10 to the 8th, and divide that whole sucker by our previous answer, and we get a final orbital velocity of whatever, around 1,000 some meters per second, which is a little bit over 2,200 miles an hour, is the orbital velocity of the moon. V equals around whatever, 1,111.7 meters per second. So in a nutshell, that's number 3.